So how was your break just now? Going to the Jumat break, I guess. That must be exciting. Okay. Welcome to the kinetics of a particle class. Today we are going to talk about force and acceleration. So I'm pretty sure some of you have done physics back in high school.
Yes.
And can anybody tell me what's the symbol for force in physics?
F.
F? Okay. What about accelerations?
A.
A, good. Okay. So if you notice, I put like a bold letter there. And why is that? Does anybody know?
It's important.
Yeah, they are both important. But physically, they are actually vectors. Okay? They're both vectors. Okay? That means they have direction, and also they have magnitude. Okay? So magnitude. As you know that force also they're quantified by unit. Okay? And does anybody know what the unit for force? Anybody? Newton? Wow, we got a good student here. He's one good student. All right, Newton, which is N. Okay. So this Newton is because of Sir Isaac Newton. Okay. So Sir Isaac Newton, one day he was just sitting in the evening under an apple tree, and then suddenly the apple hit his head. And once the apple hit his head, he thought about F equals to ma. This great equation right here is what our topic is today, for today. Okay? So let's see. So we know now F equals to ma. Instead of bold, I can also use the arrow on the vectors. Okay. So in this case, F equals to ma. So, and we also know that the unit is Newton. And what's the unit for mass? So M here is mass, is kg, and A is meter second square. So in other words, the unit Newton can also be interpreted as kg, meter per second square. Okay? So whenever you are doing a test or an exam, make sure after you multiply both M and A, you end up with kg, meter per second square, if the question is asking about how much the force generated in one question. Okay? So let's do an example here so we can closely imagine how this is used. So imagine you have a 10 kilogram of box of mass. Let's make it a circle to indicate it's a frictionless floor. And suddenly there's an applied force of, for example, 5 Newton. Okay? So the question could ask, how much acceleration generated by the circle. Okay. So here we have an applied force F of 5 Newton on your right direction. Okay. So F in the right direction, 5 Newton. Okay. And what are the information that we have now? We have mass, right? So mass is and kilogram. Okay. So the question is asking how much acceleration is generated. So how do we use this equation to answer? Anybody? All right. So we have F equals to ma, and we want to find the acceleration. So the acceleration A is F divided by m. Okay. So that means F in this case is 5 Newton, and m is 10 kilogram and 0.5 Newton per kilogram. And to check your answer, you can always check the unit. So Newton per kilogram, and that means kilogram. So Newton, we know that is kilogram meter per second squared, and divided by kilogram, we can cancel that out, and it becomes meter per second squared. So that means this is the unit for acceleration, and we got the acceleration there, right? So from this question example and this equation, I want you to reflect back. What if the mass is high? Okay, using this calculation, what if the mass is, for example, 20 kilogram? What would be the acceleration? Will it be decrease or increase? Anybody? Should we decrease?
Decrease.
No.
No?
It's a good try, but no. it should be decrease, right? Because the denominator is high. So, well, since the answer was wrong, I think I should make a physical example. So let's push this aside. And so we have this. Imagine in one dimension is a circle, right? Which is a heavier particle than a marker pen, right? So this particle, if I apply the same kind of force, it only generates acceleration very mildly. So it doesn't travel much because acceleration is low. So if I put a lighter one in a lower mass particle, okay, if I give the same amount of acceleration, it goes faster. So I hope you can make a connection between F equals to ma correlations. And I think that's for now, for today. Make sure you read chapter 2 for tomorrow's class. Thank you so much.